Okay. The default device. If you guys want to see the whiteboard closer, I might be using the whiteboard for later. Oh. Okay, there we go. Hang a second, that works. Anyway, they're not using whiteboard right now, so that's fine. I really wish this would raise better, but who here was at the very first introduction meeting for SkySNL? Okay. And I kind of went over for you guys the introduction for SkySNL images now as well. So, like I said previously, the most important thing is data, right, for your AI model. If it doesn't have enough data and doesn't have kind of good quality data, you won't be able to learn how to make good predictions, right? And so a very important step once you have your data, the next step is going to be to do some data processing. This isn't super complicated necessarily, and you won't necessarily need to use all of these tools, but it's good to kind of understand them because maybe I'll present 10 different things you can do and you'll use only one or two of them. But it's good to know, I don't know, which one you might need to use. It's kind of what I talked about previously, right? We have the workshop, which is happening right now. Today it's happening on Wednesday, but usually again, it will be on Fridays. We're kind of trying to make AI accessible. So even if you haven't made an AI before, it's exactly what this workshop is for. And yeah, I talked about Random Stars as our theme, and you have to make your own AI under that theme. They also want to mention, yeah, so next meeting will be in a different room. It will be on Friday, but just for next week, this room was booked. So we're in 215, I believe, for next week. So I'll send an announcement about that. Okay, so actually I already mentioned this, but why is data important, right? Is all of the things that your AI knows is purely from the data. You showed an example of a picture and you say, this picture is a dog. So it kind of learns, okay, this is what a dog looks like. You showed a picture of a cat and it kind of learns this is what a cat looks like. And you show it thousands and thousands of examples, or at least hundreds and hundreds, and eventually you'll be able to learn from that. So data is really important because everything your AI knows is purely comes from the data. One thing that's very important though, as a very first step, before you do anything with your data really, is to split up into training data and testing data. So why is this important? Basically, the training data is the data that your model learns on. Testing data is data that you use literally like a test for your model. Your model cannot see the test data when it's learning. It's kind of like how a professor, when he gives you an exam, he's not going to show you all the test, well, usually doesn't show you all the test questions and answers, right? The test data is meant to actually check whether the model learned something general. The reason is that if let's say you have, I don't know, a couple hundred images of dogs and cats, and you're trying to select which one's a dog, which one's a cat. If you only check how well it does on the training data, what the model will often do is it will just memorize each of those 100 images of dogs or cats, and then just output perfectly for each one. Then when you send in an image that it hasn't seen of a dog or a cat, it will just completely fail because it's not one of the images it memorized. So the way you check for that is you have a separate section of test data that it hasn't seen, that it can't memorize. So just usually the split is that if you have a data set, you'll split I don't really need to draw the 70% is training and about maybe 30% or maybe 80% training, 20% testing. So just a small amount that's reserved that you can see, okay, it can actually still work when it hasn't learned this data. That basically represents that in the real world, you don't know that your model is at what your model is actually going to see, and you might even not know the real results. For example, you want to basically verify that it can work on stuff outside of the stuff that's actually been trained on, and it can work in the real world. That's what the testing data is for. Types of data. So some of you guys are doing, don't worry about what a tensor means for now. It's a lot simpler than you think. It's basically like a list. A lot of you are doing data points. which is like basically just numbers, right? In my example with the temperature, then there'll be a bunch of numbers where it's like humidity, pressure, wind, right? So what you'll have is you'll have a Google Sheet. Let's see, is this visible in the, yeah, okay. You'll have a Google Sheet and it might have like wind. It will have pressure. Honestly, can't think of it. What was I saying? Humidity? I mean, it's a made up example. What? Right? And then it has a bunch of numbers, right? I mean, you guys know what a sheet looks like, right? And this has, a couple hundred or even thousand examples, right? And this is the data that is in a sheet. So it's usually saved as a .csv file. You need to be able to actually get that into Python. Specifically, PyTorch is what we're using for our AI models. Some of your other guys might be doing projects where you're using images. So in terms of images, you obviously have like a .png file or a .jpg. And obviously, when you think of an image, this is usually going to be in each image. It's important to think about what an image is. It's a list basically of pixels with height and width. And then each pixel has an RGB value. So each pixel has 3 values. And then you have a list of those images. So that's actually a lot of data sometimes. So you might want to be careful with how you're loading that. Now, when you want to get this into Python, the way we kind of like take these two different formats and they're kind of still the same is we think of them both as tensors. Tensors is basically a generalization of a list or an array, or if you guys know what a vector is. It's basically a series of numbers with some sort of dimensionality. What dimensionality means is just that it could have lists of lists. So let's say I have, are you guys familiar with just like a normal Python list? Yeah. So let's say I have a list of numbers like here, of like 7, 8, 4. You can actually just make this into what's called a one-dimensional tensor, right? Which is just, you would just do, I mean, basically it is a tensor, right? Already, it's just one dimension. The way you could have second dimension is that basically instead of each of these entries being a number, each of these entries is in itself another list of numbers. So maybe this list is 8, is 0, 7, 4, right? So that's another list here. And this is 3, 8, 2, right? And you can continue this, whatever. And so you can probably kind of see it starts extending downwards. So it's a 2-dimensional tensor. And in fact, if you notice the similarity between our 2-dimensional tensor here and the sheet is that when you convert your CSV, what it will often be is it will be converted into a 2-dimensional tensor, where basically the first index of the tensor will be, let's say, the wind. The next will be the pressure. The next will be the humidity, et cetera, et cetera. Does that kind of make sense?
Everyone knows what a tensor is, right?
It's like a list of lists.
Or it's an n-dimensional array. So a 2-dimensional tensor is a matrix.
Yeah. So here's kind of also another visualization on the screen here. I mean, 4-dimensional is obviously kind of hard to visualize, but you can just imagine this, the cubes get stacked. So now let's go on to indexing these tensors. Suppose I have I'm just going to call it like a tensor. And I've loaded my CSV data into it. The way you index it is very similar to Python, but use like some more commas. If you want to access, let's say I have this as my CSV. If I want to access the first column, I just do tensor 0. And this will access all of the wind, for example, values. If I want to access a specific wind value, oh, by the way, obviously it starts at 0, not at 1. So wind is the 0th one, and pressure will be the 1. Then you just put 0, comma, whatever specific one you want to index. So 0, and then let's say I want to index 0, 1, 2, 3. I want to index this one. Then I do 0, 3. And this would result in the number 8 if I loaded this CSV into the tensor. Because I'm selecting the 0th one and then the 8th one down. Does that make sense? So where this gets more complicated is once we talk about 3 and 4 dimensional tensors, especially if you guys are dealing with images. So I think an image is a 2 dimensional tensor, which would be like reasonable. But really, when you think about it, each image, you're not really processing one image at a time. You're processing many images. So really, you have a list of images. So if you think about like a list of 2 dimensional images, like let's imagine each square is like, some image. It's a guy, it's a tree, and you have, a list of these images. Really, each image is 2 dimensional. And then the third dimension is which image you're selected, right? So what you get is 3 dimensions. But that's actually also not entirely accurate to say an image is 2 dimensions. Because if you look at an image specifically, each pixel, let's say you have 1 dimension, right, the height and the width, right? But if you look at each pixel specifically, there's not one number in that pixel. Like this, it's not like this pixel's value is 8. What that pixel's value is actually is something like, I don't know, 10 or 100, which is the RGB values. So red, green, and blue. So really, there's an additional dimension to each image, which is the color. Maybe if you guys are using grayscale images, they'll be 2 dimensional. But in most cases, you'll probably want to do color images. Actually, in some cases, if you want to reduce your data and you think that the color doesn't matter, you can actually process your images as grayscale, in which case it would just be 3 dimensional. But for most of you, I believe you are doing color. So in the case that you are doing color, this is actually a 4 dimensional tensor. So let's say I do tensor, and I want to access, let's say, the third image, which would be, again, index 2. And then I want to index, I don't know, from that image, I want to select this pixel. So that would be, I don't know, like the 10th row or something, let's say, and then put it down here. The 50th column, let's say. Then this would give me this would give me 3 values, which are the RGB values of this specific image at this specific pixel. If I wanted to get specifically like the blue value, then I have to do 1 to get specifically the blue value. Does that make sense? Now, typically, you're not going to be like indexing 1 pixel at a time, obviously. So one last thing that's pretty actually useful with tensors, and the reason I introduced this part, is when you want to select like multiple, let's say a group of images or a group of just data points in the tensor. But it could be persistent as well. For that, you use notation. Instead of putting a number that you're indexing, you use what's called slice notation, where you do start, and then a colon, and then end. Essentially, this will tell you select everything from the start to the end. And then if you don't include start, it will be 0. And if you don't include end, it will be the last element. So if I do tensor, let's say I actually want to split and get, like I said, the training and testing data. And I want to get the first, let's say I have 1,000 images, and I want 70% of them to be training. So I select the first 700, right, out of 1,000. So I want to select, instead of selecting 1 image, I want to select all, like 70% of them, right, which would be all 700. So I'd select from, actually, I would select from the start, but I could just exclude the start because I know I'm selecting them. And I could select up to 700. So what this would do is, because there's no start, it does 0. And because the end is 700, this will return basically the same tensor, but just with only the images up to 700. Now with that, I want to ask you guys maybe a question. What happens if you do tensor this? Just a colon and no starter. Anyone have any? Yeah.
It selects the whole data set.
Yeah, exactly. It selects all of the images across this dimension. The reason you might want to do this is, well, you probably wouldn't do this specifically because this is just the same result, but you can actually do this for inner dimensions. So let's say for whatever reason, I want to select only the red channel. Let's call it, when you say RGB, those are called channels for images. Let's say I only want to select the red channel. with images. I might select all the images. I might select all the rows and all the columns, right? So that's all dots, 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 dots. But then when it comes to selecting the channel, the RGB, I do 1. So what this does is selects across all the images, selects all their pixels, because it's selecting all the X and all the Y values for the pixels. But then in terms of the actual like RGB, it only selects 1. Oh wait, I guess this would be G maybe, but whatever. It would only select one of the actual colors for it. In the same way, if you want to only select like any other kind of dimension, you'll very often see these colons used like that. There's a lot of other operations you can do with tensors. There's like shuffle, which will like maybe shuffle around the elements, which is very important. And remember, when you're shuffling, you like, let's say at the start of the day, say you want to like mix up your data, right? Obviously, it's important to specify very often what dimension your operation is operating on. So in the case of these images, I want to shuffle their order. I would want to shuffle them across the first, or really the 0th dimension. So across this dimension, right? Because I want to like swap this image with this image. If I shuffle across like another dimension, like let's say I accidentally shuffle across the second one, that might shuffle literally these rows of the pixels here, which would obviously completely change the image, and all your images would become garbage. So you won't necessarily always need to use those like indexing commands very thoroughly, but it's good to understand when you're loading the data in, kind of, okay, I can load them into these like multi-dimensional arrays, and then think about like how many dimensions it is. It's especially more important if you're doing an image data set, just because they're like 4 dimensions, so it's kind of less intuitive how it's working. But I would say again, you won't necessarily use this, but it's good to understand. Specifically, I meant to mention this. Specifically for converting the .csv file to a tensor, you can use a library called Pandas. Pandas. It will convert it to what's called convert to a data frame, what's called a Pandas data frame. And then you can convert the data frame to a tensor pretty easily. I wouldn't worry too much about that. It's just like a couple lines of code. The nice thing about the Pandas data frame is you can do a bunch of stuff like to view the CSV like nicely. And it can even like visualize like, are there any outliers? Are there any missing values? Stuff like that, which we'll talk about soon. If you want to load a like .png or a .jpeg file into a tensor, there's basically I would recommend PIL, Python image library you can use, and that's also just like a couple lines of code. You can find it online. I'll also be giving you guys a resource at the end of the day with that. Yeah. So the other thing is the actual data processing part. So there's like quite a few things you want to just make sure maybe their data set doesn't have. You don't have to do all of these, but for example, especially for a CSV, sometimes you'll get like some weird one online and a bunch of the rows might be like empty, or maybe a bunch of the values might be 0. Like let's say this was measured from, let's say that, again, a temperature example, and let's say for every value, the humidity was 0, right? Like let's say, I don't know, they just measured it and they put 0 for every humidity. Maybe that weather station didn't have humidity data. That means that basically it's what they said, the way it's called in Pandas is that the values are not unique because they're all the same. And so in the Pandas data frame, you can actually do .unique, and it will tell you, okay, how many different values does humidity actually take? And if you notice that it says the only value humidity ever is 0, well, it's obviously not a very useful one, and you have to cross it out and basically not use it because it's useless. It's all 0. Null values is pretty explanatory. Sometimes the values will just be null. And depending on what it is, maybe null means 0, or maybe null means that you can't use it. So you'll have to think about what happens if you have null values. Class distribution. So this is more for classification problems. So thinking of I don't know, let's say you're doing classifying like stop signs and stuff for like cars, right? And like you're classifying stop signs, you're classifying yield signs, you're classifying all these different kinds of signs, right? If your data set is 90% stop signs, then your classifier will just 90% of the time just choose stop sign, regardless of what gets inputted. So when you want to look, you want to list out what your classes are. So let's say your classes are, I don't know, stop sign, yield sign, whatever else, speed limit. And you want to make sure these are like roughly equal in their distribution. It doesn't have to be perfect, but it shouldn't be like very wildly different. Um, yeah, and you can fix that by basically just what's called like undersampling, which is where you use a lot less of one class, but that ultimately gives you less data. So it's kind of not very good. You can also try oversampling, where you try to like kind of use these classes more and train on them more, but then you're training on kind of the same examples, which is also not ideal. So ideally, you would just find more examples such that your data set is well distributed. It's up to, if your data set is big enough that you can kind of cut out the extra examples, that's fine. The last thing is rescaling data. You'll see this online. It's not always necessary, but I just, in case you guys see it, rescaling data is basically before you input it into your neural network. One thing you sometimes do is you'll see them, either they just rescale it from 0 to 1. So let's say your pixels go from 0 to 255 usually. Not sure if you guys know this. 0 to 255. So like, for instance, they'll just divide that and they'll divide that by 255, and then the range will be 0 to 1. It's still like debatable if this helps. Like I said, a lot of the ways neural networks work isn't entirely clear. But yeah, this can help it sometimes. And also if it's like some weird value where it's like from 7 to 64, you would also have to, subtract 7 first and then divide by the range. So just rescaling to 0 to 1. Another thing people sometimes do is actually kind of different, where it's like rescaling it to kind of be more like what's called the bell curve, the normal distribution. Actually, this should go down. Where this normal distribution, just really quickly, I don't want to like explain it too much, but these normal distributions, they're described by the average, what's called the mean, and they're described by the standard deviation, STD-dev, which is basically just how like wide this part is. And there's a very easy way you can take your data set and just calculate what the like mean and standard deviation is. And sometimes what people will do is they'll like rescale it, which is they'll subtract the mean and they'll divide by the standard deviation, which will mean the average will be 0 and the standard deviation will be like 1. Or if you see actually variance, it might be variance, not standard deviation. But that's like not something you have to really get into. But if you see people do that, that's what they're doing. And you can try it for your data set, and there'll be, you don't have to worry about like how you calculate the average. I mean, you can probably figure out how you calculate the average. You don't have to worry about how you calculate the standard deviation. And there's stuff that will do this automatically for you. So it's up to you. These are a bunch of different tools. Like I said, like your data set, it might be totally fine. It might not have any of these issues. It might have all of these issues. So it's up to you to kind of decide if, like, look through, if you're using a CSV, especially, I would say like sometimes those CSVs, like you download one from somewhere and it's like not processed at all. Then you might need to do these things. For image data sets, it's probably less likely that you'll have to like have, like, I don't know how you have null value for an image unless like one of the images is all black or something all white. But it's a good idea to look at class distribution always. The other ones are kind of, you can look through your data set and see if it might be an issue. It's just things to consider. If you want to understand like how you actually do this stuff, we've made a collab. So let me see. Oh, so yeah, first, make a copy of this file if you want to like run it, because I think it's owned by us. Make a file, make a copy right here, file. Save a copy in Drive probably. So here, if you guys haven't found a data set yet, you can totally find one here. Maybe ideally it would relate to the theme, but if you want to just work on an AI without submitting to the competition, it's really fun. Here we show basically some examples of like, okay, here's where you have pandas as PD and you read the CSV. So it's super simple how you read that. Other examples here, which I talked about, right? Info tells you basically like just a bunch of like, okay, what are all like columns here? What are the types of columns? Here's how many are non-null. So this this is an example data set, and you can see that like there's a lot here that are missing. You don't have to make a graph, but you can just like do this df dot is null. That's why kind of pandas is kind of convenient because it has a lot of convenient functions like is null that like the tensors won't have. But you can just do df dot is null and then see like how many are null. And as you can tell, the yellow here in the graph, you don't have to make this graph, but here it's nicely shown in the graph where, oh wow, a bunch of them are yellow, so they're missing. There's also stuff here, the amount that are null, you can do, yeah, ones that are duplicate, like if all of them are exactly the same, stuff that's formatting consistently, obviously, stuff that's outliers. Here's what I was talking about scaling. So that way they're scaled kind of from 0 to 1 rather than from like whatever different range they are. Somewhere here there was the unique thing. I just scrolled past it. But yeah, you can look through this and this will give you kind of a couple ideas maybe on what you can do for your data set. Yeah, sorry, the link, I'll send it in the chat as well. It's right here. Oh. So this guy's no. Okay. And then the other thing is the send it in the chat if you guys want to look at this collab. The other thing is at the end here, loading images. You don't have to necessarily use this method, but this is the method I use, which is from PIL import image. So this is what I was talking about with Python image library, import image. And this will basically, you can do down here, image.open. And then you take the image path and you do .convert RGB. Actually, I'm not sure how well you guys can see this. Now, what this other code does is it basically does a bunch of other like transforms automatically for you. One here is, for example, transforms.toTensor. So like I said, you want to take your image and you want to put it into a tensor. So this will just, if you do transforms.compose, then it'll basically run a list of transforms on your image before like when loading it. And you can look at this code closer, but you do like transform and then image, and then it'll basically turn it into a tensor, for example. But there's a lot of other transforms you can do, and you can click on this link to see them. And some of them are, for example, resizing your image. Maybe your images are different scales. Maybe you want to crop them. Actually, if you want to crop them, you can use the indexing I taught you guys if you want. But there's also, you'll notice there's some that are says random, like random resize, random jittering, random cropping. This is kind of now, I was talking about Pandas CSV, now I'm talking more about specifically for images. This is something you might want to consider only for images, really. But if you do happen to be using an image data set, you can do what's called augmentation, where you just take the original image and then you do like some random like effect to it, like flipping it or like rotating it or blurring it or adding a little bit of noise. So in this case, if I'm classifying an image as a cat or a dog, this is still a data point that's accurate. Like this is still a photo of a cat. All these are still photos of a cat, right? But I've like basically made my data set way bigger because I can add a bunch of random like effects to it. And to the neural network, this image that's flipped vertically looks completely different from this image, right? Like the inputs are all different. But it's still a data point that's accurate. Like this is still a photo of a cat, right? So you can increase the size of your data set, which again makes your model more robust, and without having to actually find and collect more images of cats. Does that kind of make sense why I might want to do this? Because when you're like, let's say you're using this model in the real world and someone's taking a photo of their cat with their phone and they're using your model, they're not going to take it at like the perfect right angle that this is, right? They might take it upside down, they might take it rotated, they might take it's kind of blurry phone photo, right? There might be like some noise, darker, right? Whatever. You want the neural network to not focus on stuff like how bright the image is or how vertically flipped it is. So you basically add a bunch of extra examples that have those random effects. That's kind of an extra thing you can do for your model to make it more robust. Again, it's not super necessary. Are there any questions about this or the previous stuff? Yeah, so I've described like a lot of different techniques you can do, right? Like selecting tensors, like add indexes, selecting class distributions, checking over your data set for non-null values, doing data augmentation. In all likelihood, you're going to use like maybe one or two of these techniques at most. You're not going to do all in one data set, especially because some of them are only for images and some of them are only for CSVs. But it's a good idea to know maybe which one of these you might need to do, depending on your data set. It totally depends. And it could help your results a lot. That's all I have. All these slides are going to be posted and the recording as well. Yeah, I'll be walking around basically helping you guys if you guys have any questions about like, oh, where can I find a data set? How do I do any data processing stuff? If you've already loaded your data set, maybe what do you want to do next after that? I'll be kind of talking about that. For the people on Zoom also, you guys can hang out too. I'll actually join a breakout room and talk with you guys in like a moment. So, or just message me if you have a question. That's it. I'll keep this link. I'll keep this slide up just so you guys can see the collab. If you guys, it's also in the Discord.